Looking at these, I've got to find some trig values based on points on what we call the terminal side of an angle. And the first thing I'm going to do is draw a triangle. And for my first one, we've got 17 and 17. That means we're going 17 to the right and 17 up. I'm going to use the Pythagorean theorem to figure out that this would end up being 17 times the square root of 2. Okay, so let's see what we have to solve. So this says cotangent of theta. So if our angle theta is here, we know that cotangent is like tangent, but it's flipped. So if tangent of theta is opposite over adjacent, cotangent of theta is going to be adjacent over opposite. And here, that's my adjacent, that's my opposite. I also notice that's my x and that's my y. So this is really saying x over y. And when I divide those two, I get 1. Cotangent of theta is equal to 17 over 17, which is just 1. Next up, we're looking at the sine of theta. And here we're going in a clockwise fashion, which means we have a negative angle. But that doesn't matter so much for what we're looking for, because we're going to build our triangle using our reference angle. And here we've got 5, we've got the square root of 11, and I've got to figure out my hypotenuse. So 5 squared plus the square root of 11 squared is going to be equal to some c squared. So we get 25 plus 11 is equal to c squared. That means that c is going to be 6. All right, so now figuring out what this angle is, sine is going to be the opposite divided by the hypotenuse, which is the square root of 11 divided by 6. Here we're given some information in terms of some trig stuff, and we've got to find some other trig values based on this stuff. I'm going to start off with the inequality sides of this. So by that I mean we're going to take a look at the first one. We've got sine of theta is less than 0. In other words, sine of theta is negative. I'd like to take a minute to just think about our angles in a circle. And if I've got an angle here, we know that in terms of values, sine is the opposite divided by the hypotenuse. We also know that the hypotenuse is always going to be a positive number. So the only way sine can be negative is if our y value is going to be negative. That gives us some idea of where to begin looking for this. So we're talking about the bottom half of our x and y axes. Okay, so now that we figured out kind of the realm that we're looking in, we're talking about tangent. And tangent is negative 3/4. We know that based on the same idea, that tangent is taking these two things and dividing them. And if I were to do that, we could either have a positive divided by a negative, or we could have a negative divided by a positive. We know we have to have one of those two things because we have a negative value here. So if we're talking about a y divided by x, we're talking about either in the second quadrant, where we'd have a negative y divided by a positive x, or in the fourth quadrant where we have a positive y divided by a positive x dividing into a negative y. Okay, so that gives us kind of an interesting thing. Oh boy, I just did that. That's the second time today I've done that. I can undo that. Cool. Then we are going to go and do some stuff up. So what I'd like us to notice is that when we are looking at these pieces, once we kind of set this up, we're in really good shape. Because what this is telling us is that we're looking at an angle that's below the y-axis. That's our theta. And here we've got negative 3 for the y. We've got a positive 4 for the x. And using the Pythagorean theorem, that would give me 5 for the hypotenuse. Cosine of theta is going to be the adjacent divided by the hypotenuse, and that's going to be 4/5. All right, looking at the second one of these, same thing. I'm going to start off with my triangle. We've got an idea that cosine is the adjacent divided by the hypotenuse, and for this to be for this to be negative rather, because that's what less than means, that means that we have a negative x value. So cosine is going to start us off being negative on the left half of my graph. Let's now take a look at the other piece of information. So cosecant, we know that this is the reciprocal of sine, and we already said that sine had to do with the y values because it's opposite divided by hypotenuse. Cosecant would be hypotenuse divided by opposite, but we end up with the same positive and negative things. Here we have a positive value that can be positive anywhere in the first two quadrants. The overlap here is going to be in quadrant 2. That means that my angle, I can do this in this purple color again, 17/8 would be hypotenuse over opposite. So there's my 17. Here's my 8. Using the Pythagorean theorem, that x value is going to be 15. Okay, in fact, going in this direction, x is going to be negative 15. Cotangent, we know that is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent would be adjacent over opposite. And based on this quadrant, we're looking at negative 15 for adjacent and 8 for the opposite.